So yeah, hello everybody. I'm Daniel. I work at WhatsApp at the developer infrastructure team, and yeah, I'm here to talk about like debuggers for Erlang, a new one that we just got. So yeah, I mean, before talking about like a new debugger, like why even a new debugger? Like, is there a need for that? So like what's the landscape of debugging with Erlang and Beam languages? So one option is debugging with tracing, like directly, or any tracing-based tool like DBG, Redbug, whatever. And I mean, tracing is amazing. You can just be like you have your system floating in space 36,000 kilometers away. You cannot stop it. You cannot upload random code to debug something because it might crash. And you just like run some commands, and suddenly you start getting like information about like what's going on inside. That's I like to say that it's a like superpower of the Beam. So yeah, that's amazing. Just to get an idea, how many of you guys would say that normally use any kind of tracing for debugging? Can you like raise your hand? Okay, a couple. So tracing is super cool. One objection I have with tracing is that it's great if you are troubleshooting something on your live production cluster, like Unbeatable. But first, if you are doing things as best as possible, you shouldn't end up in this situation, or not very often, where you really need to do this. And if you are developing something locally, debugging a test, your like a copy of your service running locally, an e-script, maybe tracing is not that comfortable to set up and to use. So of everybody that raised their hands when I asked, who normally use tracing for local development debugging? Okay, fewer, but still. So what I think most people do in this case is they do like printf IO format based debugging, which now you have like your system with you. It's very easy to go and change whatever you need. It's faster than I'm terrible at remembering like syntax for new DSL or whatever, but IO format, I can always put it in danger. So you just go, change your program, do stuff, run it. You get a stream of things on standard output. You start like finding where your problem is. I mean, it works. I've been doing that for years. So who normally does this type of stuff when okay, and surprised. So you know the pros and cons. So like it's a bit like the feedback loop is slow. You need to change your code, rerun, find the output. Then you need to remember to clean up at the end. I mean, it's doable, but it's annoying. And then there's the third way, which is like if you have a debugger, like let's say you have in Java, Python, C, or whatever, you do these things where you put a breakpoint on the program, you run it, it stops, and then you take your time. You can start like inspecting what's going on, this variable, that variable, say run a little bit more, stop again. Like when you can use it compared to just putting printf statements, it can be much faster. To be fair, some people on other languages at least can't work without a debugger, and some people ignore them, but for people that like them, it's a super productivity kind of thing. And Erlang has been shipping with a debugger in OTP since, as far as I understand, since the very first open source release. You can set breakpoints, you can post execution, whatever, look at variables. Now, can I get hands? How many people use this in practice? Okay, so numbers were coming down. So yes, much fewer people use them. And at WhatsApp, we had this, like we run this frequent, like twice a year surveys for engineers saying like, how's the tooling? So you have like multiple questions. Are you happy with debugging tests? Yes, no. Are you happy with version control? Yes, no. Are you happy with debugging? And for years, the satisfaction thingy with debugger was like low, and we were saying, okay, but you have already a debugger. Like, why are not using it? And the feedback we get is that people were trying to use it, but it wasn't working as intended. So like they would give them like a couple of tries, doesn't work, next time back to printf, IO format, whatever. So yeah, we try to understand a bit like why this was happening and what could be done. And for a long time now, we've been working along the OTP team, trying to come up with an alternative to the step debugger that currently was shipping with OTP, starting with OTP 28. Both the VM and the compiler have like some new debugging extensions that we can now leverage to write like a new step debugger that we hope fixes some of the problems there were with the venerable debugger app. And yes, we built a debugger based on this. It's called EDB. It's like GDB or whatever, but with an E. We've made it open source. We've been using it internally at WhatsApp as main Erlang debugger since March this year. I think it's the main tool. Talking with people, they are quite happy. So I think it's a good time to like introduce it to the rest of the community. So what I'm going to try to do is a live demo. It can go wrong. Fortunately, Roberto has been taking tap dancing classes, and he promised that if it goes wrong, he will entertain you while I try to figure it out. But hopefully there's no need, or hopefully there is need, I'm not sure. So okay, so let's try the demo and be gentle if it doesn't work. So I'll be using. Can you see well with these colors? Or is it okay? Cool. If there's issues, we can change the theme. I'll be using VS Code. I'll be using vanilla OTP 28.1, I guess. I don't know which one is installed. And I will be using the vanilla Erlang language platform extension for VS Code, the one you should be using if you're using VS Code, in my opinion. But this gives you like ELP, all the equalizer, diagnostics, etc. And that's mostly it. And let's do this kind of game. I don't know if game is the word, but let's assume like we are called and we were like, there's a new online store for Acme that for whatever reason they didn't call it Acmeson as they should have, but they didn't. They shipped it very quickly, but now they have the problem that users are saying that it doesn't work, and we are parachuted there trying to figure out what's going on. The first thing we know is that this thing comes with some tests. So let's open the Acme suite. This is a common test thingy. And there's a test for order placing, that it is what we know that doesn't work. And the extension gives us this fancy button that we can press to run a test. So we could try that. Okay, test passed. So test passed, but the system doesn't work. Great. Let's look into more details. So the other special thing in this project is that if I open the rebar config over here, this thing is defining a test profile. So you can do rebar as test something, and in the erlops, so the compiler options, when using this profile, we are adding this beam debug info new flag. Like that's the only change. So back to the test suite. What we could do now is set a breakpoint here, like the red dot, and click on the debug button and pray. Okay, I'm gonna close this. Okay, cool. So this thingy means that the execution stopped there, and we can already see here that we see the value of a config variable. It's this variable here. By the way, I will feel a bit silly during all the talk because like this is sort of table stakes in most languages, but still I'm excited that it's working for Erlang. So we get stuff here like what's the value of the variables. We can step over if I click here. Oops. Next line, and we have the value of this variable, and same if we do it again. And this gives us, so we can either try to make sense of the value of the variables like this, or we can expand them and say like, oh, this is a list, the first value is whatever, this is a tuple, the first value is this or that. The same with maps. We can expand list of values, typical debugger stuff. So, so far so good. Let's try to see what happens when we place an order. So instead of step over, I'm gonna use step into. So now we are inside the place order function. I have no idea what this is doing, but we can just like navigate a bit the code to try to figure it out. So, okay, this is all good. This is spawning some process that it's running order stamper loop. Okay, another process, great. So now this is calling stamp items with an empty accumulator and the list of items. What are the items again? It's the thing that we are buying. Okay, cool. So let's step into that function. See what happens. So it seems that the first thing this does is send a message to the stamper process that we created, and now I have I'm worried whether I ruined the demo or what, because like this stamper process is running this stamper loop over here, and I can see that it is expecting to receive an item, what we are sending here, but it also has like this 5-second timeout, and I've been speaking for more than 5 seconds. So I suspect that this didn't work. So if this had happened, then the current process should have received the tired of waiting message right now. Okay, and let me collapse this thing. So apart from the locals, there is this process section that is giving us, let me collapse this thing, some process information. And it says messages in queue 0. So somehow it looks like the process didn't get a message. So let's step over once again, and change. We see a 1 here, so the process now has a message. Is it the tired of waiting thingy? No, it's the message we get on the happy path. So what does this mean? So it means that when we hit these breakpoints, it's not just the process that was executing that we stop, but we stop everything with some light quotes, everything inside the VM. We can sort of see it here in this call stack component. So this is showing information about every process in the VM, and we can see that it says that 475, which just happens to be self, the one we are stepping on, is post on a step. But then there is like a long list of processes that also say post. In particular, I don't know which one is Stamper. Stamper is 507. Let's look at it. 507. So we can jump to 507 and see what it's currently doing, and it's stopped on the receive, waiting for a message. I think it has already sent this one and is looping again. So cool, that's good. If you ever used the old debugger for OTP, I think this was one of the main problems. Like you would pause on a process, but everything else kept running, so your debugging session was quickly ruined. So good. This seems to work. Let's continue trying to figure out what's going on. So what can we do here? So okay, we received the message. We are done. Okay, so this part seems to work. We got like a list of stamped items that whatever it's doing looks correct. It says stamped. Okay, so let's go to the generate invoice function. Let's step in. Okay, what is this doing? This is calling a customer name function. Okay, probably not interesting. Let's skip it. I can see that customer name. Okay, this is like an IO list. I cannot understand IO list. What can we do? One thing that we can do here is open the debug console, and this is like some sort of REPL that you get inside the debugger. So we can do something like, let's say, Unicode characters to binary customer name. Yes, sorry, okay. Good, and we get like the short thingy. If you don't want to like keep writing this all the time, because like these variables are going to show up a lot, like in a debugger, you can just add them here. So let's add the same thing: Unicode characters to binary customer name. And what do we get? Okay, we got the right thing. It's just that the window is too small. Okay, good. So good. We are doing like successfully normal debugger stuff. So now we are calling to a function that it's pricing the items. Okay, good. Sorry. Let's see what that thing is doing. So let's step into. Okay, create an accumulator, call another pricing function with an accumulator. Okay, let's go there. And what is this? Okay, so yeah, okay, so we understand the problem. Like someone bytecoded this in anger, ran out of tokens, shipped it, and like, okay, I wouldn't know. We know how to fix it. We need to prompt it and wait. So what happens now? Okay, like we could just end the debugging session, but like I'm wondering what happens if we try to, let's say, step over at this point on an error. So let's try it. So step over an error. We ended up on the catch statement for the try that originally called this thing. What was happening sort of is that yes, we were inspecting the call stack. found where there was a try catch, a catch handler, and make sure that we land there. By the way, one thing that you could also do at this point is start looking at the caller frames. So here we are looking at this process at the top of the stack, but we could say like, okay, what were we in the caller? What was the caller location of this? So we could like, we know that we are in this generate invoice call and that we come from the test suite. Again, normal debugger stuff. So okay, we know the problem. We can continue stepping out, and here we can see that the invoice says invoice unavailable. So it's not order placed. Oh, so we got an order placed, but the no, this is sorry. Yes, we are not on the test case yet. We are returning order placed, but with an invoice that says invoice unavailable. Go out, and here we know that this passed because we were ignoring the content of the argument of the order placed result. Cool. So we figured out what was the problem. Now, so let's finish the execution of this. Let's stop it. So like when I look at the code, so we know that the problem was in the Acme catalog thingy where we had like this not yet implemented. This is what we figured out. But I'm seeing that there was a test for the Acme catalog. There is a suite. So like, why wasn't it caught there? It's the next thing that we should check. So we go there, we find a test. And what is the test doing? So it takes the function that has the problem, Acme price items 2, and it's mocking it, okay? And then calls price items, and it checks that it got the result from mocking. Like, this is typical LLM, like amazing, no one checked, went straight to production. So good. This we now have like a good understanding of like what happened with this system. So, but now there could be like a pointy question. Is like, okay, you have a test over there, and I see that it's mocking stuff. It's mocking Acme catalog. Like, what happens if you try to use your debugger there? And I would say that's a good question. I don't know. Let's see. So let's run this test. Let's step over. So how many people here used Mech for mocking? Good. How many people know what it does under the hood? So for those who don't, so Mech is a mocking library. You can give it a module and say like, I want to mock it. Maybe replace functions by some other values or whatever. And the main thing you need to know is that under the hood, it takes the AST from debug info for that module, recompiles it under a different name, like, I don't know, in this case, Acme catalog _ Mech or something like that, and adds a proxy module called Acme catalog. So I would expect that if I try to step in here or set a breakpoint here, this shouldn't work, like really shouldn't work, because the Acme catalog module doesn't really exist. What it's called Acme catalog is some kind of proxy that Mech provide, and the real thing is a different module. So let's verify that this doesn't work by stepping in. What? Okay, it is. No, what? No, this should work. Okay, I think let me see if I can do it like this. Let's open. Roberto, come do your thing. So let me try to put a breakpoint here. I'm okay. Okay. This was working on my laptop. This is not mine, but it's okay. So after this failed part, this should have worked. I need to check why it didn't here. Yes.
Maybe you need to add the breakpoint while the machine is not running before starting the debug session.
That's a good question, but no. There, like, it's a good. I mean, it's a good point. No, and the error says line is not executable with. I think it got compiled wrong somehow. We. Yeah, I think I know the problem. We are not using the latest version of Mech, maybe. Okay. So this should have worked. Sorry. What we should have seen is that this would have gone to the module even if it's mocked, and the reason why it should work is because Mech has been recently instrumented to be aware of this debugger and can do a trick where after recompiling like the new version, renamed version of the module, it does a secret call and tells the debugger, hey, if someone asks about Acme Online storage, use this module instead. Yes?
Would you see the make code or it just show you the, what would it show you?
So I'm so sad. So you would have seen the code. So what you would have seen is in the call stack an intermediate call coming from mech eval something between where you are now and the module, and we would have seen the Acme catalog as being that module because we do the debugger does some module name conversion under the hood, like.
On a pass-through, it would just show me the original module.
So yes. So yes. So what will happen under the hood is that you say, I want a breakpoint on Acme catalog line 22, and the debugger will say, okay, you want it on Acme catalog mech line 22, and set the breakpoint there. And then when it sees the breakpoint on Acme catalog mech, this says, okay, this is Acme catalog, and gives it back to you. This needs collaboration between mech and the debugger or any other tool that does this. So yes, sorry that part didn't work, but I promise that it does work. And yeah, the other thing like I wanted to show, since we are here, like apart from using this fancy thing that comes from the extension, you can use like vanilla VS Code debugging stuff. So if you define like in your project like a launch JSON file in the VS Code directory with some magic invocations like run river as test shell plus evaluate this magic thing that I'm gonna give you, then you can get like a river 3 shell session here. Let me close this a bit, where you could, let's say, put a breakpoint here. We have one already, so maybe do Acme catalog price items whatever empty list, and we got it here. And you could have a similar setup where instead of running river 3 shell, you could attach to your development node. It's already running, but you connect to it and start debugging. So this is more or less the things that you could do at the moment. So yeah, that's for the demo. Let's go. It went okay, mostly okay. So questions. What about like nice VS Code, but I don't use VS Code. I use Emacs, Vim, whatever. So the debugger doesn't have anything VS Code specific. Like we have this extension that does some fancy things like the debug lens or whatever, but that's just a VS Code thing. Everything else uses like what it's called a debugger adapter protocol, which is like LSP, but for debuggers. So it's a kind of server, and you can tell Vim, Emacs, whatever, your favorite one, to use that one. I haven't done it because I don't use them. We left some pointers on the README of the page of what you can do. Please try it and report and update the documentation. Let's make it easier for other people to use it. But in principle, like, the support is there. There's nothing VS Code specific. What else? How it works? I'm gonna go very quickly. So there's the IDE, like VS Code, Emacs, whatever you're working on. When you try to launch a new debugging session or attach to a running node, it runs a node, like a debugger node. It communicates over standard in, standard out using some Microsoft protocol for debuggers. And this node uses like the API of EDB, like a module, EDB module, to connect to the debugging node using either using Erlang distribution. Essentially, at the moment, it's what it's done. And inside, once it connects to that node, it injects a lot of debugger code there and starts a particular process, like a debugger process. This one will interact with the new APIs in the Vim to set breakpoints, receive notifications when a breakpoint is hit, whatever, and do all kind of orchestrations like pausing, suspending every process every time a breakpoint is hit on any process, and stuff like that. What else? So what you need to know is this relies on two things. First, the compiler now can emit. It always had a debug info option that generates like the AST. Now it has a new Vim debug info option that generates more stuff. It generates like instrumentation to be able to set breakpoints in lines, and it emits information about what's this variable name maps to this internal VM register at this particular line, things that the debugger needs to use to show this information. If you ever program in C and use like a C debugger, it's like using GCC with the -G option, the one that puts debugging symbol information. And then the other thing that you need to do is run the Vim with the +D option, D for debugger. The intuitive idea is that you don't want to run this accidentally on production and freeze your node with all your customers there. So like you really need to opt in to do this. And when adding this option, you pay a price. Like some optimizations are turned off because then the compiler can't track where variables are mapped to. Some binary handling optimizations are disabled. In practice, for development, we've been using it on like large system, and it's fairly okay. And coming soon, hopefully in 28.2, there will be another option added, because like one caveat we have so far is that the compiler is very aggressive eliminating variables that it doesn't need anymore, that are out of scope. So we need a way to say, chill out, man, just leave the variables there. I want to see the value. So it uses more memory, but otherwise, like you set a breakpoint, you can no longer see what were the value of the arguments of the function because they were optimized away already. So you will need to add this one again to your rebar config. How about other Vim languages? So far we support only Erlang because it's what we use at work. But if there are any Elixir or Gleam people, there's not much Erlang specific here. Like if Elixir can put the right line number in your stack traces, then it's essentially everything that is needed. There might be little changes that we need to do, set up a CI so we can check what happens under Elixir, but it should be easy to extend this to support other Vim languages. Elixir people, Gleam people, if you're interested, please get in touch. So takeaway. There's a new debugger. If you like debuggers, it might be pretty useful. Try it out. There are gonna be rings that need to be ironed out, but like send issues. It's the debugger part is written in Erlang. It's probably fun to work on it if you want to hack on it a bit. So by all means, we need help with getting it to work under Windows for various reasons. If you use Windows, let's talk. And yeah. Yes, and this was like a long project, started like I would say February last year. A lot of people got involved, both within WhatsApp and the OTP team. I hopefully didn't forget of most of them, so thanks everybody for the hard work. And yeah, I don't know, if you use QR codes, I think you will go to this exact slide with it. And yeah, that's it, thanks.
Amazing. I love debuggers. All right, questions? Back here.
From what I can yell.
The stream can't hear if I'm not here.
So I don't see any reason why this couldn't work with multiple nodes, right?
So we have half support for it, but it hasn't landed yet. So yes, it should work with multiple nodes, and most of the infrastructure is already there, but there are some details that need to be finished, like you want to run them all in sync, and I think that part needs some coordination between all the dApp servers and stuff, but yes. If you want to help.
More questions?
And what if the node tested node is inside of Docker image, for example? How to solve this?
So I don't know, we need to think about it, but like in principle right now, if you want to launch, so the question is, you have a running node or a node you want to launch?
I can test, and I have visual code outside of virtual box of the Docker running Docker image. So I'm running the test. I create the Docker image, and I cannot kick it out because.
Yeah, but so as long as the Docker, like the process in the Docker image can talk TCP to something outside of the Docker image, that should work. Or alternatively, we need to think something. But like my point is, it might not work right away, but it should be feasible because it's using some kind of either distribution for now, but it could try to use something else. Like as long as you can do some form of TCP, it should work.
Any other questions?
Thanks for the talk. I checked with WhatsApp GitHub. There is a EDB. Is it the one that?
Yeah. It's
so
this one. Yeah.
Does it also have a console like GDB that I can use the command like in the console? I can go next line and so on.
So technically, you can use the EDB API from like you start a node and you write the EDB commands. It's possible. I've done it. It's not it's not a. It's going to be an Erlang REPL, and you run the commands from there. It's not going to be super ergonomic, but yes. And if you are interested in building something like that, it would be awesome. Yeah.